a little bit more in depth on enantiomers. So in the previous video, we had the whole big flowchart of isomers. So we already know that enantiomers have the same molecular formula, the same connectivity, and that they are non-superimposable mirror images of each other. And in the last video, I gave the analogy of my hands. My hands are mirror images of each other. But there's no way I can rotate one of my other hands to really line them up perfectly. Even if I flip it over, my palm side is not facing the same side as the back of my hand. So there's no way I can rotate one of my hands to make it exactly like the other one. So same idea with enantiomeric relationships. So if we look at the example we have here, we have a mirror right here. And so if we look at molecule number 1 and we draw the mirror image of it, we're going to get molecule number 2 over here. So you can see that there's a mirror in the middle and that we have exactly the mirror image. So just like my hands, I can't take molecule number 1 and rotate it in any way to make it the exact same as molecule number 2. So if we take molecule number 1, rotate it 180 degrees, you would get your X being on the opposite side. You would get your Z, which was behind the plane, being in front of the plane, and then you would get your Y, which was behind the plane, your Y being in front of the plane, behind the plane. So once we rotate it, we get a nice lineup with the W and the X, but our Y and Z are not lining up. There's no way I can take molecule number 1 and rotate it to make it the same as number 2. And this is the idea of enantiomers. They are mirror images of each other, but they are not superimposable. I cannot put molecule number 1 on top of number 2 and them line up perfectly. So along with enantiomers, there's this concept of something called chirality. And all that chirality means is that you have a central carbon atom that has 4 different things attached to it. So let's look at these 2 examples, 1 and 2, and let's determine which of these is chiral. So in number 1, I'm going to write below it what things are attached to the central carbon. So we have our central carbon atom right here. We know we have a bromine. We have our implied hydrogen. And then we have a methyl group. I'm going to write Me. And then we have another methyl group. So to be chiral, you need 4 different things attached to the central atom. This has 2 of the same thing. So this is not chiral. Therefore, you do not have an enantiomer of this compound. And the reason is, if I drew the mirror image of this compound, it's the exact same compound. There's nothing different about the mirror image. So therefore, the non-superimposable does not apply to a non-chiral compound. However, if we look at example number 2, we have our central carbon, we have a bromine, we have a methyl group, we have an ethyl group, and then we have our implied hydrogen. So this central carbon atom has 4 different things attached. That makes this compound chiral, which means that it could have an enantiomer. If I drew the mirror image of this chiral compound, it would be the enantiomer of it.
I hope you found this video to be really helpful. The concepts and information presented in these videos will be true no matter what Organic Chemistry 1 class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the 1st floor of the Sid Richardson building. You will find all the details you need about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.